when the prompt becomes visual. Vision-centric jailbreak attacks for large image editing models. Recent advances in large image editing models have transformed how we interact with AI-generated visuals. The shift from text-driven instructions to vision prompt editing, where users convey intent through marks, arrows, and visual cues, has dramatically increased usability and control. But this evolution comes with a hidden cost, a new frontier in AI safety risks. Today, we're unveiling a previously overlooked vulnerability, Vision-Centric Jailbreak Attacks, or VJA, where malicious intent is embedded entirely within visual inputs, bypassing traditional safeguards designed for language-based prompts. This isn't just a theoretical concern. Our research reveals that state-of-the-art models like Nano Banana Pro and GPT Image 1.5, despite their robust safety systems, can be compromised with visual-only attacks, achieving success rates as high as 80.9%. The attack succeeds not by tricking the model with words, but by exploiting its ability to interpret visual signals, which current safety mechanisms are ill-equipped to detect. To study this threat systematically, we developed IESBench, the first standardized benchmark for evaluating safety in image editing models. Unlike prior benchmarks focused on text generation or general multimodal understanding, IESBench is built specifically for image editing, with over 1,000 visually prompted attacks across 15 risk categories, ranging from privacy violations and copyright tampering to evidence forgery and dangerous instructional visualization. These categories are organized hierarchically. Level 1 targets individual rights, Level 2 focuses on group-based harm, and Level 3 addresses societal risks like disinformation and violence. Each attack is carefully curated, using high-quality base images, precise visual annotations, and multimodal reasoning to ensure realism and reproducibility. The results are striking. While commercial models like GPT Image 1.5 and Nano Banana Pro reject most malicious text prompts, they remain highly vulnerable to visual ones. For example, an attack asking to remove a watermark from a photo, delivered purely through a red arrow and a circle, can be executed successfully over 70% of the time. Meanwhile, open-source models such as Bagel and Qwen-Image-Edit, which lack dedicated safeguard layers, fail completely, with 100% attack success rates. Why does this happen? Because modern image editing systems are now deeply multimodal. They process visual signals with the same sophistication as language, relying on vision language models to understand complex instructions. But safety mechanisms remain rooted in text, focusing on detecting harmful words, not harmful images. This creates a critical safety misalignment. The model interprets the visual prompt correctly, but the system fails to recognize the intent behind it. This is where vision-centric jailbreak attacks become so dangerous. They don't rely on keywords or phrasing. Instead, they embed malicious instructions directly into the visual layout, using color, shape, font, size, or even hidden symbols. A red circle around a face isn't just a highlight, it can be a command to alter identity. A small arrow pointing to a license plate isn't just guidance, it can be a request to falsify data. And because these cues are subtle, they evade detection by traditional guardrails. But here's the breakthrough. We've developed a training-free defense that restores safety without adding external models or slowing down inference. Our method uses a lightweight safety trigger. You are an image editing safety evaluator. Please review the image and text of the user to predict whether the edited image will be safe legal, appended to the input prompt. This trigger activates the model's internal safety awareness through introspective multimodal reasoning. By forcing the model to reflect on the edit in language space, where safety alignment is stronger, the attack surface is redirected back to the domain where defenses are most effective. The results? A poorly aligned open-source model like Qwen-Image-Edit sees its attack success rate drop from 100% to just 66.9% after applying our defense, bringing its safety level close to that of commercial systems. And crucially, this comes with negligible computational overhead. Our method reuses existing KV caches, adding only 3% extra latency. It's efficient, scalable, and deployable in real-world applications. We also tested the robustness of our defense in zero-shot settings, where it correctly identified 75% of malicious inputs, proving that the core mechanism works not just in theory, but in practice. This research exposes a fundamental truth. As AI becomes more visual, so must our safety frameworks. The era of text-centric safeguards is over. We need systems that can reason about visual intent, detect deception in image layouts, and defend against attacks that hide in plain sight. Our work doesn't stop here. We've released IESBench as a public resource, complete with 1054 attack samples, detailed annotations, and a scalable MLLM-based evaluation pipeline, so researchers and developers can build safer, more trustworthy image editing systems. The future of AI image editing is powerful, flexible, and intuitive. But with that power comes responsibility. Vision is no longer just a medium for expression, it's now a vector for manipulation. And if we don't build defenses that match the complexity of visual interaction, we risk enabling a new wave of harmful, deceptive, and dangerous AI outputs. The prompt is no longer just a sentence. It's a drawing, a mark, a signal, and when that signal is malicious, we must be ready to see it.